Unit 1. Periodicity of elements and their properties. Lesson 2. Graduation of the properties of elements in the modern periodic table. In this lesson, we will study the graduation of three properties in the modern periodic table, which are atomic size, electronegativity, and finally, metallic and non-metallic properties. Atomic size. The atomic radius is used as a measure for the atomic size of the atom, and its measuring unit is picometer or pm. Now the following: picometer is equal to 10 to the power negative 12 meter. Let's talk about the graduation of atomic size of elements in the periodic table. In periods, by increasing the atomic number from left to right, the atomic size decreases. This is a give reason question. By increasing the atomic number from left to right, the atomic size decreases. Because the attraction force between the positive nucleus and the outermost electrons increases. As you can see from this video, if we try to take an example, we will take lithium as example. This is the size of lithium and this is the size of fluorine. As you can see, the size of lithium is much more greater than that of fluorine. This is because the atomic size of elements decreases in periods by increasing the atomic number from left to right. In groups, by increasing the atomic number from up to down, the atomic size increases. And this is an important give reason question. Give reason 4. By increasing the atomic number from up to down, the atomic size increases. This is due to the increase of the number of energy levels. As you can see, if we take the sodium atom as an example, sodium atom contains 3 energy levels. The element that is under it in the modern periodic table is potassium, which contains 4 energy levels. So as the atomic number increases in groups, the number of energy levels increases, and thus the atomic size of the atom increases. The second property that we will study is electronegativity. What's meant by electronegativity? The ability of the atom in covalent molecule to attract the electrons of the bond toward itself. In this case, the electronegativity of chlorine is higher than that of hydrogen, so hydrogen will attract the electrons of the bond toward itself. Let's talk about the graduation of electronegativity of elements in the periodic table. First, in periods, as you can see, by increasing the atomic number from left to right, the electronegativity increases, as you can see from this scale. But in groups, by increasing the atomic number from up to down, the electronegativity decreases, as you can see from this scale. From up to down, electronegativity decreases in groups by increasing the atomic number. According to the previous information, we can conclude that fluorine is the highest element in the electronegativity. This is because it lies at the top right hand side of the periodic table just before noble gases. So fluorine has the highest electronegativity, which is equal to 4. We can classify the types of bonds according to the difference in electronegativity as follows. As you can see from this video, these are the electronegativities of some elements. What are the types of bonds according to difference of electronegativity? The first type is ionic bond, and this occurs if the difference between the two elements forming the compound is more than 1.7. Like this between sodium and chlorine and sodium chloride, the difference between them is 2.1. The second type is covalent bonds, and we have two types of covalent bonds. If the difference in electronegativity is less than 1.7, it is a covalent bond. And if the difference is relatively high, which means near 1.7, so we have a polar covalent compound. But if the difference is relatively low, which means that it is much more less than 1.7 and approximately equal 0, so it is nonpolar compounds. If the difference is 0, so we have pure covalent bond. Ionic compounds. They are compounds in which the difference in electronegativity between elements forming their molecules is higher than 1.7. Examples: sodium chloride. The difference between sodium and chlorine is 3 minus 0.9, which is equal to 2.1. 2.1 is more than 1.7, so the bond between chlorine and sodium is ionic bond, and sodium chloride is an ionic compound. Polar compounds. They are covalent compounds in which the difference in electronegativity between elements forming their molecules is relatively high. Examples: water, H2O, and ammonia, NH3. As you can see, the difference between electronegativity of hydrogen and that of oxygen is equal to 1.4, which is less than 1.7, but it's still relatively high, so water is a polar covalent compound. Nonpolar compounds. They are covalent compounds in which the difference in electronegativity between elements forming their molecules is relatively low. Examples: methane, CH4, hydrogen sulfide, H2S. We will see that in these two cases the difference between carbon and hydrogen is 0.4, and between hydrogen and sulfur is 0.4, which is relatively low, so they are non-polar compounds. Problem: calculate the difference in electronegativity between the two elements forming ammonia molecule. Then identify the type of bond between them. First, we have to know the chemical formula for ammonia. The chemical formula for ammonia is NH3. So we have to calculate the difference in electronegativity between hydrogen and nitrogen. The difference between them, don't worry, the numbers will be given, is 3 minus 2.1, so the difference between them is 0.9, which is relatively high, so ammonia is considered a polar covalent compound, and the bond between nitrogen and hydrogen is polar covalent bond. Let's talk about the third and final property, which is metallic and non-metallic property. Elements in the periodic table are classified into four main kinds, which are metals, nonmetals, metalloids or semi-metals, and noble gases. Let's compare between metals and nonmetals. The first point of comparison is the outermost energy level. The outermost energy level in metals contains less than 4 electrons, but in nonmetals it contains more than 4 electrons and less than 8 electrons. During chemical reactions, metals tend to lose electrons and change into positive ions, while nonmetals tend to gain electrons and change into negative ions. Examples: for metals, sodium Na11, magnesium Mg12, aluminum Al13. For nonmetals, we have fluorine F9, chlorine Cl17. Let's talk about metalloids or semi-metallic elements. What's meant by metalloids? They are the elements which have the properties of both metals and nonmetals. Note the following. It is difficult to know the metalloids from their outermost electrons. This is a give reason question. Give reason 4. It is difficult to know the metalloids from their outermost electrons because they vary from 3 to 6. The number of electrons varies from 3 to 6 electrons. So we have to memorize them. We have only 4 examples for metalloids. Bromine, its outermost energy level contains 3 electrons. Silicon, its outermost energy level contains 4. Arsenic, its outermost energy level contains 5 electrons. Trillium, its outermost energy level contains 6 electrons. Now let's compare between positive ion and negative ion. Positive ion, it is an atom of a metallic element that loses 1 electron or more during chemical reactions. For example, if we have a sodium atom, during chemical reaction it will lose its outermost electron. What's meant by negative ion? It is an atom of a non-metallic element that gains 1 electron or more during the chemical reaction. For example, if we have a chlorine atom, it will gain 1 electron, so its outermost energy level will be filled with electrons. For positive ion, it carries positive charges equal to the number of lost electrons. This sodium ion will carry only 1 positive charge, which is equal to the number of lost electrons. But in negative ion, it carries negative charges equal to the number of gained electrons. For chlorine, it will carry only 1 negative charge equal to the number of gained electrons. For positive ion, the number of its protons is more than that of its electrons. As you can see here in sodium ion, it contains 11 protons and only 10 negative electrons. But in negative ion, the number of its electrons is more than that of its protons. For this chlorine ion, it contains only 17 protons and 18 electrons. Its electronic structure, this means that the electronic structure of positive ion is similar to that of the nearest preceding inert gas. For example, the electronic configuration of sodium ion is similar to that of neon. But for negative ion, its electronic structure is similar to that the nearest inert gas that follows. The structure of chlorine negative ion is similar to that of argon. The number of energy levels in ion is less than that in its atom. For example, this is the sodium atom, it contains 3 energy levels. This is the sodium ion, it contains only 2 energy levels. For negative ion, the number of energy levels in it is equal to the number of energy levels in its atoms. This is chlorine atom, it contains 3 energy levels. This chlorine ion, it contains 3 energy levels also. Examples for positive ions such as sodium positive 1, magnesium positive 2, aluminum positive 3. Examples for negative ions, chlorine negative 1, oxygen negative 2, phosphorus negative 3. Let's talk about graduation of metallic and non-metallic property in the periodic table. First, let's talk about them in periods. Each period starts with strong metal in group 1A. Then the metallic property decreases gradually by increasing the atomic number. So metallic property decreases in periods by increasing the atomic number, till we reach metalloids. Then the non-metallic property appears and increases by increasing the atomic number. So non-metallic property increases in periods as we go from left to right by increasing the atomic number, till we reach the strongest non-metals in group 7A or 17 just before group 0, which is noble gases. But in groups, we will talk about metallic groups such as group 1A and 2A. In groups, the metallic property increases gradually as we go from the top to the bottom. And this is an important give reason question. Metallic property increases in groups by increasing the atomic number. This is because the atomic size increases. As we go from up to down in groups, the atomic size increases, and hence the metallic property also increases. For example, in group 1A, cesium is considered the most metallic element in group 1A, while lithium is considered the least metallic element in group 1A. In groups, but in this time we will talk about non-metallic groups such as group 7A. The non-metallic property decreases gradually as we go from the top to bottom. Give reason 4. This is because the electronegativity decreases. In group 7A or 17, fluorine is considered the strongest nonmetal in group 7A, while iodine is considered the least non-metallic element in group 7A. Now let's talk about the chemical properties of metals. The reaction of metal with number 1, dilute acids. The reaction with oxygen, and finally we will talk about the reaction with water. So to study the chemical properties of metals, we will talk about the reactions with dilute acids, oxygen, and finally with water. Reaction with dilute acids. Some active metals, such as magnesium and zinc, react with dilute acids, such as hydrochloric acid, HCl, giving salt of acid, and hydrogen gas is evolved. Mg plus 2HCl diluted salt of acid, which is magnesium chloride, is formed and hydrogen gas is evolved, as we can see from this video. We can do it in another way. We can prepare a piece of zinc and we will try to collect the evolved gas, which is hydrogen. To prove that this gas is hydrogen, we will approach a flame to it. As you can see, it will burn with a pop sound. This proves that this gas is hydrogen. But inactive metals such as copper don't react with dilute acids and no gas is evolved. As you can see, this test tube contains a piece of copper and you can see there is no reaction. So Cu plus 2HCl diluted, no reaction. Metals react with oxygen, forming metal oxides. For example, the reaction of magnesium with oxygen, as you can see in this video, a white powder is formed which is magnesium oxide. The chemical equation for this reaction is 2Mg plus O2. Heating, it will give 2MgO. Some metal or basic oxides, such as magnesium oxide, dissolve in water, giving alkalis or metal hydroxide, which turn litmus solution into blue. For example, MgO, which is magnesium oxide, plus water, H2O, it will give MgOH by 2, which is magnesium hydroxide. This is the reason that metal oxides are called basic oxides, because they dissolve in water, forming alkaline solution. Some metal oxides such as iron 2 oxides don't dissolve in water. So we have to say some metal oxides dissolve in water because we have some examples for metal oxides which don't dissolve in water such as iron 2 oxide. The final reaction is the reaction of metals with water. The reaction of metals with water depends on the position of metal in the chemical activity series. What's meant by chemical activity series? It is a series in which metals are arranged in a descending order according to their chemical activity. This is what is called chemical activity series. As you can see, it is divided into 4 categories. We have to memorize them. The first category contains potassium and sodium. They react instantly with water and the hydrogen gas evolves, which burns with a pop sound. The second category contains calcium and magnesium. They react very slowly with cold water. The second category contains zinc and iron, and they react only with hot water vapor at high temperatures only. The final category contains copper and silver, and they don't react with water at all. As you can see, what's meant by chemical activity series? It is the series in which metals are arranged in a descending order according to their chemical activity, from more active to less active and finally to inactive. Let's see the reaction of elements with water. This is the reaction of potassium with water. It happened instantly. This is the reaction of sodium. Also, it happened instantly. If we try to collect the evolved gas and we approach it from the flame of the candle, you will notice that it burns with a pop sound. The second category is the reaction of calcium with water. As you can see, this reaction is slower than that of sodium and potassium. The reaction of magnesium is much more slower than that of calcium. Here you can see the reaction between magnesium and zinc sulfate, and also between zinc and magnesium sulfate. This only to show the difference in their activities. This is to show the activity of copper and silver. As you can see, there is no reaction at all. Now let's talk about chemical properties of nonmetals. The reaction of nonmetals will be with only dilute acids and oxygen. Reaction of nonmetals with dilute acids. Nonmetals such as carbon and sulfur don't react with dilute acids such as hydrochloric acid. Reaction of nonmetals with oxygen. Nonmetals such as carbon and sulfur react with oxygen, giving nonmetal oxides, which are known as acidic oxides. For example, C plus O2, by heating, it will give carbon dioxide. If we heat a piece of coal in oxygen, carbon dioxide will be formed. Also, if we do the same with sulfur, by heating sulfur strongly and putting in a container that contains oxygen, sulfur dioxide is formed, which is a non-metal oxide or an acidic oxide. Non-metal oxides dissolve in water forming acids, which turn litmus solution into red. If we bring dry ice, which represent carbon dioxide, and dissolve it in water, carbonic acid is formed. And as you can see, by using litmus solution, its color will change into yellow or red, because carbonic acid is an acid. So when non-metal oxides dissolve in water, they will form acid. By heating sulfur strongly and by putting a litmus paper at the mouth of the test tube, you will see that the blue litmus paper will change into red. This proves that sulfur dioxide is an acidic oxide. Now let's compare between basic oxides and acidic oxides. Basic oxides, they are metal oxides. Acidic oxides, they are non-metal oxides. They are formed by the reaction of metal with oxygen, while acidic oxides, they are formed by the reaction of non-metal with oxygen. Basic oxides, some of them dissolve in water giving alkalis, but all acidic oxides dissolve in water giving acids. The solutions of acidic oxides turn litmus solution into blue, while the solutions of acidic oxides turn litmus solutions into red. Examples for basic oxides such as sodium oxide and magnesium oxide. For acidic oxides, we have carbon dioxide and sulfur dioxide. Finally, let's talk about something called amphoteric oxides. What's meant by amphoteric oxides? Let's do this experiment. First, we have a test tube that contains sodium hydroxide, and this one contains hydrochloric acid. This is an alkaline solution, and this one is an acidic solution. As you can see, aluminum oxide reacted with both of them, and in each case of them, it will give salt and water. Gave reason for some metal oxides such as aluminum oxides Al2O3 are known as amphoteric oxides. This is because they react with acids as a base and also with a base as an acid, giving in the two cases salt and water. Thanks for watching. This is the end of lesson 2.